Okay. Okay, so last presentation before lunch. So my name is Asi Messica, and I'm VP Data Science at Lightricks. We are a provider of very successful video and image editing mobile applications. And I gained my PhD in the area of recommender system. Okay, so we acquired Popular Pace. Popular Pace is a marketplace for creators and influencers in the social media. And this was part of a strategic move of Lightricks from being a successful application provider to provide a platform for creators. And Popular Pace, like the marketplace, the idea of the marketplace is to really match or connect between brands that are looking for creators and influencers in the social media to either create content for these brands or promote their products in the social media. So in the marketplace, like in Fiverr, right? Matching is always like core capability, and it has like a lot of business impact. And as a data scientist, of course, immediately after the acquisition, we wanted to optimize the matching algorithms of Popular Pace in order to increase their competitive advantages and really drive their business. And obviously, like if we talk about matching of creators in social media, the content that creators are generating and publishing in the social media, either images or video, is a very important part and a crucial part, right, for the matching and for understanding who are the creators and how to match them for brands. Immediately, like it was 2021, Clip by OpenAI was like the SOTA for language image models, and it was clear for us that we will use leverage Clip for the matching. And when we started implementing and researching like the usage of Clip for this use case, we found out that the vanilla Clip is not 100% a good fit for our need. And what I will talk about today is, I think, a very interesting topic these days, is like we are really living in an exciting period where we have a very, very strong language models, and different models are released every day, and we need to follow up and to see how we can adapt them for our businesses. But in many cases, the vanilla models are not like, doesn't fit our needs exactly, and we need to see how to adapt them or how to leverage them as part of a wider solution to really address our business needs. So this is what I will talk about today. Okay, so let's start like with few words about Clip, contrastive language image pre-trained model. So the idea of Clip, as I mentioned, it's a language image model, and it was trained with a huge corpus of pairs of images and text that describes the images. And what was trained actually is a text encoder and image encoder, and it was trained in a way that the vector that describes the text that describes the image, the cosine similarity between these pairs should be maximized. So the diagonal of pairs of image and text should be maximized, and like with the contrastive loss, the cosine similarity of these vectors of not pairs, like items, pairs who are not on the diagonal, should be low. Okay, so this is the idea, and what we get out of Clip is really a representation on the same embedding space. We get a representation of image and text in a way that a vector of an image that describes a text that describes the image and vice versa are close to each other. Okay, And clip is very effective for what is called the zero-shot classification. So if we want, and I didn't mention that the loss is a symmetric loss, so it was trained to find like the closest, for an image, what's the closest text vector, and for a text, what's the closest image vector. So when we talked about zero-shot classification, we have like, if we want to find like what's the object to get the class of a specific image, so how we do it, we have like vectors which describes the different classes of objects that appear in the image. We have the vector of the image, and we find the closest vector to this image. This will be the class of the image. And vice versa, like for search, if we want to search for images which contain specific object, we will look for we will take the vector which describes the specific objects, and we will look for the images which are closest to this text in the clip space. Okay, so this is really very cool, and it connects out of the box text with images. So I will focus on two use cases of matching that we have at Popular Pace. One is lookalike, and the other one is value alignment. And this work was just accepted to Rexis. So I'm very happy about that. Very proud. So what is the lookalike service? So with lookalike, in many cases, when brands are coming and looking for creators, that may be a good solution for them. They don't know exactly what they are looking for, and it's hard for them to describe it in words. But it's easier for them to point to another creator that either worked with in the past, or someone who is very famous and expensive, but they look for someone with a similar theme that talk about the same topics and publish like similar content. So like you can see here an example. So this is like the Anchor creator. You can see he's publishing content about food. And this is like the result of the lookalike service by Popular Pace. So you can see that the most similar, the lookalike creators, they also talk about food, and you can identify also the type of food that they all write. They have the same style of food they talk about. So when we started, to begin with, we thought like to leverage the clip for the lookalike service, like summarize, do some average of all the content a creator has in his social media for the content he published in the social media, and based on the vector similarity, really recommend like the most similar creators. However, when we tried it, what we saw, let's look here at an example. So we see here an image of people in front of a store. So we saw that the clip is really very good to find similarity, object similarity. So the similar images to this image is images of people, or images of people, right? It didn't capture like the uniqueness of like healthy food or something like that, that this is you see that the people are standing in front of a healthy food store. And the same here, where we see this lady driving a car, and the clip captures like different images of people driving, but nothing from her lifestyle, which is unique for her. So we looked for a way to adapt clip for this need, and what we did is we built like we used clip as an input, and we built like a Siamese network with triple loss, where we try to make two images of the same creator closer to each other, and the image of and the distance between the image from the same creator to another creator more far away, okay? And in this way, we created like a new, we call this approach same account media embedding. And in this way, we created like a creator representation that captures not only the objects that appear in the content he published, but also his unique theme. And you can see here how it looks. So here again, like we have the anchor image of the people in front of the healthy store. And the most similar images are, you know, they're all about like healthy lifestyle. And the same, where with the clip, we have like only photos of images. And the same with the lady driving a car. So while with the clip we have like people driving, here you can see different photos of ladies with similar style. In addition to the subjective evaluation, we did also a objective evaluation, where we tried, like we used different pairs of profile representation by different images of the same creator, and we tried to identify like the most similar creator among a list of 30,000 creators. And you can see here we use the hit rate at K for evaluation, and you can see here again that the same embedding is much more effective in finding like the right creator. So this was the first use case, and the second use case is value alignment. Of course, when a brand is looking for a creator to represent him in social media, in many cases, like they want that the content of this creator and this style will be aligned with the brand values. And here again, in many cases, it's not easy. Like it's soft things, right? It's not easy to define exactly like the values. And at a popular pace, the brand can enter like brand values either through the search. You see, you can add keywords of mood, atmosphere, and so on. Or when we add a campaign and look for creators for a specific campaign, we can also we let the brands add keywords with style, mood, atmosphere, and so on. And we wanted to use like the clip to filter out like the creators based on the keywords that the brand is typing. And what we understood is that the clip is very effective in finding like words of objects like dogs. Like you can see like how good it is with finding images with dog. But if we look for awesome images, the results are not so awesome. So here again, like we did some adaptation. What we did is we used CIFAR to get like 100 classes. And then for each adjective that we want to represent within the clip space, we generate two vectors. One, an image of class, and the second one, an adjective image of class. And then we subtract the two vectors and average it over all the classes. And this is the new direction of the adjective in the clip space. And you can see here the awesome results. So this is awesome. You see, we really got very awesome results. And this is intriguing. So you can see what a nice results we got. And just before lunch, tempting. So very tasty. That's it. So I will make it on time. So just to summarize the talk. So we live really in an exciting period where we have, you know, very powerful models. As data scientists, we really need to track all these releases and to understand how we can leverage them for the value of our business. Sometimes the out-of-the-box models are not a very good fit like to our needs, and then we need to find ways to adapt it. And in this talk, I shared how we adapt it at Lightricks in order to optimize the matching in Creator Marketplace. So thank you very much.